In this brief video, let's talk about how to convert z-scores, which we now know how to obtain, to scaled scores. People's scores on a test are often distributed according to the normal curve. Frequency of distribution here toward the center of the distribution at mu, or the mean. And then as they extend toward the tails, for example the lower tail, down at 3 standard deviations below the mean, there are relatively few test scores here. And similarly, as you rise above the mean, there are relatively few test scores here at 3 standard deviations above the mean. Now, z-scores correspond to the standard deviations below and above the mean of a distribution. In the case of normally distributed scores, the z-score of 0 corresponds to the mean, or mu, of the distribution. And similarly, as we move up, a z-score of 2 corresponds to 2 standard deviations above the mean. So someone with a z-score of 2 scored 2 standard deviations above the mean. Someone with a z-score of -2 scored 2 standard deviations below the mean. So z-scores correspond to how far above or below the mean the participants scored. And this is all assuming that the scores are normally distributed. And here you can see the percent. For example, if somebody scored 3 standard deviations below the mean at a z-score of -3, they'd be in the 0.13th percentile of test scorers, where there aren't very many. Or if they scored 1 standard deviation below the mean, they'd be at about the 16th percentile. Scoring at the mean, as you might imagine, well, there are 50% of the people below and 50% of the people above in a normal distribution, so they'd be at the 50th percentile, and so on, stepping on up. A z-score of 1 equivalent to 84% roughly, a z-score of 2 corresponding to about the 98th percentile. Many scale scores you hear discussed are actually conversions of these z-scores to a new, easy-to-understand scale. Let's consider a few examples. The IQ score, for example, is a conversion of z-scores. So an IQ of 100 corresponds to a z-score of 0. So test makers, when they compute intelligence quotients, start with the z-scores often, and then they convert them to IQ scores. So a 0 z-score corresponds to an IQ of 100. A z-score of 2, for example, corresponds to an IQ of 130. A z-score of -2 corresponds to an IQ of 70, and so forth. SAT scores follow the same general idea. They are conversions of z-scores, so a z-score of 0 corresponds to an SAT score of 500. An SAT of 800 corresponds to a z-score of 3, and an SAT of 200 corresponds to a z-score of -3. Now I have a little asterisk here because SAT scores often vary from year to year depending on the exact test and the students taking it. Sometimes they're off by 50 points or 75, but that's the general idea between z-scores and SAT scores. Now you may not have heard of a t-scale, but that's used also with a number of different clinical and other kinds of tests. And in a t-scale, the mean is set at 50, and that's equivalent to a z-score of 0. 1 standard deviation above the mean is a t-scale of 60, t-score of 60. That corresponds to 1 z-score of 1. 2 standard deviations below the mean, to use another example, or a z-score of -2 corresponds to a t-scale of 30, and so forth. And each of these scales is a direct linear transformation of the z-score into a number that can be passed back to the test taker that makes more sense and is easier to comprehend maybe than the z-scores with their fractions and their negative numbers. So how do you convert a z-scale or a z-scale score to any other scale? Well, you have a choice here. You can follow an equation, or you can follow some instructions. Sometimes when calculations are very simple, it's easier to follow the instructions than to follow the equation, but I do give you the equation here in case you're interested in it. To follow the instructions, to convert a z-score to any scale, simply multiply the z by the new scale's standard deviation, add in the mean of the new scale, and voila, you have your answer. For example, to convert a z-score of 1 to an IQ scale, you first have to figure out that an IQ scale, and this is typically given, has a mean of 100 and a standard deviation of 15. Psychometricians decide on how these scales work. So in that case, a z-score is going to be the z-score times the standard deviation, which is 15. That's going to equal, in this instance, 1 times 15, or 15. Then we add in the mean of 100 to get 115, and you're done. A z-score of a 1 on an IQ test equals an IQ of 115. And that's it.